All right, so this is my Google Collaboratory code for homework 4. I started off my code by just importing everything I was going to use in my code. I then set up a loop so I could get 50 iterations. I did this by starting with 1, going up to but not including 51 rounds, and increasing by 1 each time. So that has me going from 1 to 50, since 51 is not included. This range random state, RNG, random state, is so that every time I run my code, I'm not getting new numbers. It's always pulling from, I guess, like the same seed. And it's just so I can kind of compare when I was editing my code that my values, where they were changing, it was easier to see a change. This section right here is for finding my Reynolds numbers, which needed to be logarithmically spaced equally from 10 to the -4th and then 10 to the 10th. And I did that using np.log space. These are the exponents from where it needed to go from. I wanted 50 iterations, and then this is the base, so it's 10 to the -4th and 10 to the 10th. I did the same thing for the Prandtl number, but I did it from 10 to the -1st and then 10 to the 4th, again 50 data points. I then pulled a random number from each set to be used in the calculations. So this is my random Reynolds number and my random Prandtl number by doing random.choice of my equations up here, which are those log space. I then set up my initial values as stated in the problem. So that's just all what those are, and set up my Nusselt number equation using my random Reynolds numbers and my random Prandtl number from up here using those functions. This section right here is just to ensure I don't get the same Nusselt number. So I do have 50 unique Nusselt number data points. So basically it's like making sure you're not using the same Prandtl and Reynolds number at the same time to get the same Nusselt number. So that's all that is. This new loop section is another loop for finding a normally distributed random number with an average of 1, a standard deviation of 0.02, which simulates a constant relative error of 2% in the collected data. So that was me finding my random values. And then I multiplied my random number by my Nusselt number, which is what I is, to get a data point. And that's that random data point. The synthetic data point for that iteration. So this is just a little display for my answers. I showed which loop number it was to make sure that I had 50 iterations. My Nusselt number, what was being used, the random number, the Nusselt number was being multiplied by to create that noise, and the data point created from those two being multiplied by each other. And then I just printed an extra line to clean it up a bit. So you can see, scroll up to the top, I have loop number 1, the Nusselt number used, the random number creating that noise, and then my data point from multiplying the Nusselt number by the random number. So did that 50 times because I went through 50 times and none of them are the same value. And then this section I solved for the mean square weighted error for each of the initialized coefficients, all of those, and I created a model which would use a random Reynolds and Prandtl number, which could then be compared against my data, which is up here with all of those little bit of noise that I discussed earlier. I then used the minimize function to minimize that error against my original A, B, C, D, C1, C2, and C3 values. Then this last section prints my minimized error values along with the initial values as stated in the problem, and that's what we're looking for. So these are those new coefficients that create that minimized error. There we go.